Just to go through what we're going to be learning in these project, we're going to be learning how to execute a BIM execution plan, when, how, the roles and responsibilities for the organizations in the firms. We're also going to be learning when to use clash detection, and a light run through of how to run it. We're going to be looking at the best way that we found in our mid-rise project to coordinate the different trades, as well as how to transition from the design phase to the construction phase using this BIM execution plan. So, to give you a bit of background on the project, the mid-rise, the BCJC mid-rise was a 64,000 square foot, 4-story office building. It was partially occupied during the construction by 2 offices, the Broward Sheriff Office and the Public Defender's Office. And they were planning on combining all different offices, some lawyers in here. They were planning on adding in the clerk of courts, all related to the court, which actually was across the street from our building. The project, we started the project in 2013, and up to the final construction. The construction was completed in 2018. Just to give you a brief look at what we had created in our model. The project was completely 100% BIM. Every single component in the project was created in Revit, and down to the skeleton, all the pieces. So let's go to the BIM execution plan. So, what is a BIM execution plan? We created this document as a way to organize our different firms, to just give them the roles and responsibilities for the project, the procedures, the file structure. It's just almost like a giant instruction manual for the different firms. The project, in this case, we were doing this as the first project for the Broward County, which involved about, I want to say, 6 months of deliberation, just to kind of create the first draft of this execution plan. We were attempting to be one of their formats for future projects. So this was a constantly evolving document. We went through 7 revisions, major revisions, and minor revisions here and there. And as I mentioned before, as the project developed, we were finding ourselves constantly evolving this document. So from our document, we have our sections of our table of contents. I'm going to focus on the bolded items during this presentation. Non-bolded are more general information from the different firms. The first thing I want to talk about today is project goals. So we set up a chart in the document to detail what organization would be working on what their goals were, what programs they were going to be using. This is a simple breakdown for the architects, structural engineers, civil engineers, etc. To break down, just as our firm ourselves, we were in charge of course, the architects and project managers were doing the design, the existing conditions. This was a renovation after all. Took about 2 months to get all the existing conditions modeled after, and it was a lot of work on that one. Especially working around all the offices that were active, and we had to work with them in order to, around their schedule, to get the information. Now the BIM managers were working in the behind the scenes. They were doing the clash detection. They were doing the coordination. They were really working hard to get all these different offices working together as one coordinated machine. Let's talk about the organizational roles we had in the project. So this graphic shows how we handled our organization in the project. We entered this into our BIM execution plan specifically because the state, the county was very strict about the chain of command, and all engineering firms were under the architect, and anything we were going to discuss with the construction engineer had to go through the county first, and vice versa. So there was an RFI that was going to be eventually generated. It would have to go to the county first before any of us even saw it. In this document, we set up procedures for meetings. In this project, we had weekly meetings with the A&E team. We had BIM meetings with the BIM managers. I actually had a bit of interaction with both. I took a lot of roles in this project. I was drafter at one point. I was designer. I was the project manager and the BIM manager at different points in the project. So I was involved in all these meetings, and it was very intense meetings too with the clientele, because we had not just the owner representative, we also had 4 separate heads of the departments for each office, all butting heads of what they wanted to do in this project. In there, in that same document, we set up the project delivery schedule. In this case, because we wanted to keep the client up to date, the client requested that the documents be delivered to them on a weekly basis at 5 p.m. Friday. Although most nights it'd probably be like 6, 7, 8, depends on the submission. But there's always a weekly upload to our shared FTP site in order to provide everyone backgrounds for their project as well. So in that same document, we talked about the file structure. And we were using the typical tools we use, Revit, AutoCAD. And we were also using Navisworks for clash detection. We were using A360 for coordination on the field, and the facility was using the facility management of the project was using the AIM system. So this is just a breakdown of each individual group that we worked with. The civil and the landscaping were using AutoCAD in this case, but now this was their best way to do it. I'm sure these days they're getting more into Revit, but only the MEP team, the structural team, and the architectural team had Revit as their primary drafting tool. There's a few items here I'll get into a little bit later in the slide, including Kobe, if you're wondering what that is. Let's go to the next slide. So we set up the instructions. Like I said, this is a big instruction manual, so we set up the file structure. Every single group had to follow this strictly. If we didn't follow this strictly, it would cause problems with the linking of the project. With Revit, if you don't, just like AutoCAD, if you don't have the right name, it won't find the file. It can cause issues with our prints. So we were very strict about it. Even when the project would upgrade to another version of Revit, we kept the same naming convention just to prevent any issues with the drawings. To the right side over here this is showing our file structure in the sense of how we link the file to the project. The architecture file in this project had everything. We linked every single model, every single CAD file, so it was one big file. And it was an intense file. It caused a lot of problems sometimes with our computers. But the intent of this was to keep it simple for the client. So when he opened up the file, he had everything in one place. He didn't have to jump around to different files to find drawings. I should bring up that the client here, the county, they had the capabilities of using Revit too, and they did most of their review from the Revit file rather than from PDFs or from physical drawings. So having that as one local file allowed them to really review it with little effort. So going a bit into quality control, we set the standards for the quality control in the BIM execution plan, but the two main items we used were visual check, and everyone does a visual check, and then we did clash detection, clash checks, interference checks. And the entire team was responsible. Every single group that we worked with was responsible for their individual portions. So why did we use clash detection? It's pretty self-explanatory. Make sure everything that fits. Make sure it all fits. Make sure it's if there's a fire-rated assembly, we were able to identify it on the spot and provide a list to the GC. Of course, with field conditions, there's always one or two that don't, well, more than one or two, but there's always some additional ones that may show up. However, it gives them a nice list so that they can verify, a checklist so they can verify that it's all completed. And of course, it reduces the amount of RFIs for coordination, which will shorten delays. The project took about a year per 2 floors, which was the intended schedule, was on time, and this coordination was a big help to it. And of course, we were also providing this as this model was intended to be a final product for the owner to use as his basis for future projects. So we wanted to give him a nice clean file that was accurate to what was there. So we used Navisworks as our primary tool. Navisworks Managed 2015 was the exact one. And we had clash detection coordination meetings every 2 weeks. Well, occasionally we'd have one every other week, depending on the phase of the project. The intention being that at the end of every week we'd have a list to review with our team. We would have a meeting every Monday morning with our MEP team. We had the MEP team generate their own reports as well, which they resolve a lot of the clashes on the spot, while other things were found to be a little bit more intensive. They would have to resolve those clashes later on on their own drafting. However, these meetings, we established the timeline, what we intended to discuss every meeting, and we established that in the BIM execution plan as just our set standard. So, just to talk a little bit about Navisworks, in order to set up a Navisworks file, these files are huge files, considering that every single file is linked into the architectural file at the moment. We had to pretty much clear out every unnecessary item in the file, remove all sheets from the file, and leave it as one big, just a 3D view, and bring it into Navisworks. It was probably about a day's worth of work just to create the clash detection, just because every single bend in the pipes were in this project. Once you bring it into Navisworks, you can set up every single. You use work sets in Revit all the time. You can use those same exact work sets as your layers for Navisworks. So you set up the mechanical, the structural, the electrical, all these different layers, and you can test them all and figure out what is interfering with what. You set the tolerances, and you generate a report. A sample of that report is right here. This was our mechanical versus structural. This is just 6 clashes of I think about 50 or so that this report had generated. And we provide this, the red and green items. The structural was the red and the green would be the mechanical. We provide this. It gives you the exact location, the coordination, the clash point rather, the element ID, which you can type into your file and find the exact object that's interfering and resolve the clash. I mean, you put in a duct through a project, through a corridor, right there you might create 30 clashes just because of the structure. So a lot of the clashes that we generate are resolved with a simple drop of an item. I thought this would be an interesting to see here is our own clash log from our project. So at one point we had about 2,000 clashes happening, and with the nature of the project, as you're adding more information to the project, the rate that the crashes were growing versus the rate that the resolutions were fine, it was not exactly the best for the first few months, and eventually we found our balance and we were able to finally reduce our clashes down to about 256, which were found to be on-field coordination items that we could not resolve in the model, such as we had a lot of hanging cable, pendant lights in our project that would require slight twisting of the cable to make it work versus a duct. It also allowed us to find, as I mentioned before, it also allowed us to find our 1 hour rated walls versus our MEP, and that let us identify a nice list to the contractor. This is what you need to fire caulk. And of course, if you add anything, you add it. So, in our execution plan, we also developed the levels of design in the project. The levels of the design in the project we established the exact need for each firm's quality of their project. Level 100, 200, 300, 400, 500 are the typical levels of design. This all relates to COBE, which is the Construction Operations Building Information Exchange. This is a very important item to the client because it was related to their building management systems that they were intending to use all the information from our project from. So, to get a little bit deeper into the level design kind of follows our typical schematic design development, construction documents, down to facility management. This graphic kind of gives a good idea of what's going on, where you start with a basic column and you get down to the nuts and bolts of the project. So we set in the execution plan the requirements for each firm's development. So we developed level 100 as our standard schematic design. Level 200 was our design development, where we had our approximation of location of items. 300 was our 100% construction documents. Not on the list here, but there was a level 350, which is the MEP coordination. Their ducts, their turns, all the items were labeled in there. They are required to input non-graphical information such as the branding inside the Revit file, not just labeled in the drawing itself. So every single piece of the project was essentially almost like I can't think of the word here.
Live one.
It's a database. That's the word I'm looking for. The whole model becomes a database rather than just looking at a piece of paper in front of you that says that we have a 24 by 24 inch diffuser. That model itself is live, has the text 24 by 24 diffuser by this brand, by this manufacturer. And once we had that all established, we passed it on to the construction management team, and they took that model, and whatever they substituted, whatever they've bid out for certain items, they would insert their own information into the project. So that AON unit is now a carrier unit. So they would insert the information for warranty as well. They would insert the information for the installation date, the part pieces, all this information, which I'm going to get a little bit more into a little later on. And level 500 is, in the end result, we end up with a level 500 model. The level 500 model is used for the facility management team. This is where they take that same model, they bring it into their systems, and now they can scan a barcode and they have the information about what unit that is, what parts it needs, when it needs to be replaced, and they manage that as their facility system. So just to give you an idea of some of the responsibilities in COBE, The architect was responsible for like the model creation, the name of the item, the created on, created by is really a category from Revit specifically. Then you have the construction management team and the ownership who have to insert their own information into the project based on the actual items, the location, the exact parts and pieces, as well as identifiers for the county for that specific unit, so that if something breaks down, they can find it very easily and they can find the information on it. And also, as well, this is the second portion, just showing a bit of the MEP, where again, our engineers were in charge of the description of the drawing, but then the construction management team added in more information. So this is just a sample of our Kobe spreadsheet that would come out. This is, again, a standard format that was created for the facility management team. So this shows a portion of the mechanical section. The architecture team and the engineering team were all responsible for everything left of the purple, while everything right of the purple are the facility management team and the construction management team, where we are in charge of the type, the space, the description. This is a little earlier before our final export, unfortunately I just realized. However, they insert their serial, the installation date, warranty date, and all sorts of information for that development. So going a bit into the roles and responsibility during construction. Ooh, that does not look as well as it does on the screen. Well, if you guys have the paper charts in front of you, I would recommend looking at that instead. But we had a big hot topic on this project. So as architects and engineers, we control the Revit file through design development, through construction documents, and we typically have full control during construction as well. This project had a bit of a fight between the construction team and the architecture team. Who was in charge of the model during construction when the construction management team had to insert so much information? And we ended up finding that the best route to go was to have the construction management team control the model entirely throughout construction. They would provide us RFIs, they would provide us shop drawings through their documentation system, through the A360 BIM program, A360 Glue programs, and we would provide sketches back. We would provide hand-drawn sketches back, to which they would input into the model and create their own as-built file on the spot. And the reason we wanted to keep the responsibility on the construction management team was because a bit of liability, in the sense that if they're inserting all this information into the project, and one of our drafters deletes an item, puts it back in somewhere else, and we lost that information. So we wanted to keep it one location, so there's no fighting on who did what in the project. Look a little bit better. Once we had all that, we were given a model to review, and we